Heyo! Good morning, everyone. All right, we're going to be introducing chapter 34 today. We're going to be talking about images and mirrors. And that's both plane mirrors, the mirrors that most of us are familiar with, you know, when we shave or brush our teeth in the morning. And we're also going to talk about spherical mirrors, okay? So the first thing I want to talk about is the type of image that can be formed by a mirror, which is also called a reflecting surface. All right, so for images, there are real images and there are virtual images. Now, a virtual image is an image that forms on the opposite side of the mirror, right? Meaning you're standing in front of the mirror, brushing your teeth. That man in the mirror that you see, right, is a virtual image of you, okay? If that were, you know, a real image, you didn't need to call like an exorcist or something, right? But essentially, the definition of a virtual image is that a virtual image can only be seen by a observer, all right? It's not real, okay? The light rays have to intercept an optical system, whether that's a camera or your eyeball or something like that. A real image, on the other hand, is an image that could be formed on a surface, meaning like a projector, the movie projector. That's getting into lenses, but it's still same idea. They project out and the image can form on a surface. That's known as a real image, okay? I'm gonna write these down for you. Okay, so for plane mirrors, a plane mirror is just a flat mirror, right? It's in one plane, okay? This is the kind of mirror that most of us are familiar with. I'm gonna draw a side view of the plane mirror just like that, okay? So imagine, I'm at some distance in front of the mirror. Here's our object. We'll call it, in your book, it's given as a little arrow. It could be anything. It could be a person, right? We'll make this a person. That's a tall person. He's got long torso. Anyway, right? It could be a person, could be a penguin, whatever it is. Here's your object. And now the distance from the object to the mirror is called our object distance, and it is given by the symbol P. Now, for a plane mirror, actually in all cases, the object distance is always positive, okay? It always has a positive value. Now, for plane mirrors, there is an image that's formed beyond the mirror, right? You're looking in the mirror, you see yourself on the other side of the mirror. Okay, so we see the same image, right, of the person up there outside, or sorry, on the inside of the mirror. And this is called the image distance, and it is given by the symbol I. Okay, now, we know, we just talked about real and virtual images. This image on the other side of the mirror is a virtual image. It requires your eyeball to intercept those light rays coming back in order to see that object, okay? So for plane mirrors, when an image forms on the opposite side of the mirror from the object, well, it will have a negative value. And we know for plane mirrors that the object distance is always going to be the same as the image distance, but just on the opposite side, right? If you're 10 feet in front of the mirror, the image is going to look like it's 10 feet behind the mirror. So we can write for plane mirrors that the image distance is equal to the negative of the object distance. This is always true for plane mirrors. Okay, now let's talk about spherical mirrors. All right, so for spherical mirrors, there are two types that we're going to be talking about, concave and convex. And how we'll define that is how the mirror is curved, all right? So imagine that I am the object. I'm looking at a plane mirror, all right? And the mirror will be concave if its radius of curvature is towards the object, right? The way that I think of this is imagine I'm the object and I cave this guy's skull in, right? Like I act like I'm caving a face in or something. And now that's concave, okay? So a concave mirror has a radius of curvature that is towards the object. Here's our radius of curvature R, and it's towards the object. Okay, this will be a positive radius of curvature, again associated with a positive image distance, P. Now, a convex mirror has a radius of curvature that is away from the object. So here's our object. A convex mirror curves away from the object with a negative radius of curvature, R. All right? Again, the image distance is always positive. It's measured here. Okay? So concave has a positive radius of curvature. Convex has a negative radius of curvature. Now, for spherical mirrors, both concave and convex, the focal length, F, is equal to half the radius of curvature. So when we take that mirror and we can focus down the rays to a point, right? All the rays come in and they focus down. Here's our focal length. It has some focal length F right here. It's going to be half the radius of curvature. Now, there's a relationship between the object distance, the image distance, the radius of curvature, and the focal length for both concave and convex mirrors. And that relationship is as follows. 1 over the object distance plus 1 over the image distance will be equal to 1 over the focal length. And we know that the focal length is half the radius of curvature, so this would also be equal to 2 over the radius of curvature. Now, all of these values, we keep the signs, okay? We keep the signs that this is positive, right? If the focal length is positive, the radius of curvature is positive because it's a concave mirror, right? Then whatever the image comes out as positive or negative, we keep that sign, okay? Same thing with convex mirrors. Now, what type of images do they form? Well, convex mirrors can only form virtual images. A virtual image only, what that means is that the image distance for a convex mirror will always be negative. It will always have a negative image distance, and a negative image distance is associated with a virtual image. Now, a concave mirror. A concave mirror can form real or virtual images. It depends on where the object is, okay? If the object is outside of the focal length, right? If the object distance is greater than the focal length, then the image will be real. It will have a positive image distance. If the object distance is less than the focal length, right, meaning the object is inside the focal point, then the image will be virtual. It will have a negative image distance. And this comes out in the math as well. You can go ahead and try it on your own and find that is true. So, convex mirrors can form virtual images only. Concave mirrors can form real or virtual depending on where the object is. Okay, let's talk about magnification real quick. Okay, magnification is just a measure of the size of the image compared to the size of the object. So the absolute value of the magnification is equal to the image height, that's h prime, over the object height. Okay, we can also get the magnification as a ratio of the image distance and the object distance. So this is the overall magnification will be a negative of the image distance divided by the object distance. And the significance of this negative sign tells us whether the image is upright or inverted. Okay? So, remember, a virtual image has a negative image distance. So, a negative image distance times a negative gives us a positive magnification. So if an image is virtual, meaning it forms on the opposite side of the mirror, then it will be upright because of this negative sign, and negative times a negative is positive. However, if the image is real, if the image forms on the same side as the object, right, it has a positive image distance, then the image will be inverted. Okay, so real images will be inverted, virtual images will be upright. And I know I just mentioned it there, but I do want to clarify that virtual images form on the opposite side of the mirror from the object. Real images form on the same side as the mirror, on the object side of the mirror. Okay, let's write down a quick table with all of this information. Okay, so here's a table of all that information we just went through. For plane mirrors, obviously their radius of curvature and their focal point are infinite, right? With a flat plane, you have an infinite radius of curvature. They always form virtual images, which is associated with a negative image distance. Virtual images for mirrors always form on the opposite side from the object. The magnification for a plane mirror will always be +1, or the image is the same size as the object, and it will be oriented in the upright orientation. For concave mirrors, they have a positive radius of curvature and a positive focal length. However, they can form real or virtual images depending on where the object is. If the object distance is greater than the focal length, it'll form a real image, which has a positive image distance, and it'll form on the same side as the object. It has a negative magnification, which means it will be inverted. However, if the object distance is less than the focal length, then the image formed by the concave mirror will be virtual, which is associated with a negative image distance, and it forms on the opposite side of the mirror from the object. The orientation or the magnification will be positive, and thus it will be an upright image. For convex mirrors have a negative radius of curvature and a negative focal length, right? Both of those are on the opposite side of the mirror. It's curved away from the object. And it can only form virtual images. Virtual images are associated with a negative image distance, and virtual images form on the opposite side from the mirror, from the object. Its magnification will be positive, and thus it will be oriented upright. The image will be oriented upright. All right, so that's all the information we have for mirrors, which are reflecting surfaces. Tomorrow or Wednesday, I guess, we'll talk about refracting surfaces. If you have any questions, please let me know. We'll kick through a simple problem here, and I hope you have a great rest of your day. Take care.